Hey guys, it's Mr. Jenkins with your lesson for 3-3. This is the last lesson before the quiz that we'll do, the mid-chapter quiz, just a heads up on that. And it is about graphing systems of inequalities, which we've already kind of started on our DMR, so should have a little bit of a head start there. Learning target is I can produce and interpret a graph that represents a system on inequalities. But that doesn't make sense, so that's a typo. Should be of inequalities. All right, so on that note, we'll get right to it. I'm going to kind of go step by step on example one, just kind of how to produce a graph that represents that system of inequalities. All right, so step one can be go ahead and solve each one for y. So in other words, kind of get them into slope-intercept form. All right, so if I move 2x over, that's going to give me negative y is greater than negative 2x plus 1. Divide everything by negative 1. Don't forget to flip your inequality symbol. Y is less than positive 2x minus 1. All right, so we'll go ahead and graph that boundary line. So 2x minus 1, so start at 0, negative 1, and then my slope is positive 2. So I'll go up to right 1. I like to kind of extend these out as far as I can. All right, on these inequalities graphs. So our boundary line is also dotted, as the points on the boundary line are not included because it's strictly less than. Okay, and then when I think about my shading, I consider this inequality sign after we flipped it versus that one, right? So I'm looking at less than, so I want to shade on the low side of my boundary line, okay? Or in the case of this graph, the southeast side. Okay, and then on our other one, all we have to do is move x over to get y is greater than or equal to negative 1x plus 3, starting at 0, 3, and then our slope is negative 1, down 1, right 1. One, 2, 3, 4, 5, 6, 7, 8, 9. Well, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7. All right. And then this inequality is going to be a solid boundary line. This boundary line is going to be a solid boundary line. And greater than means we shade on the high side, or the northeast side in this case. And so we think about where's our overall double shaded region. So we have some shading, but not all here. Some shading, but not all here. And here's where we have both. We have 0 shading over here. So there you go. And remember from our DMR, you can pick any point in there and sub it into both inequalities that should make it true. And if you do that, I suggest you pick one with a 0, right? So anything kind of from this point 3, 0 on this way, 4, 0, 5, 0. Test any of those and they should and will work in both, okay? Now, that's one way to approach it. Okay, you can also use Desmos as a really useful tool. Okay, if you know solving for y and stuff like that tends to be a problem, let's look at how easy this can be on Desmos. I've gone ahead and pre-typed these in just to save that time, but you can see once I pull it up here how simple it is. So I'm going back to the original 2x minus y is greater than 1. Notice I didn't have to solve for y or anything. I could just type it just like I see it, right? And it produces the exact same boundary line we had, right? y-intercept was 0, -1, and then the slope was 2, right? Got the dotted line, got the shading underneath, everything is exactly the same. All right, same thing for the other one. Okay, so then the only really interpreting you have to do is where is the overall double shaded region, and I think it's pretty obvious that it's right here. So Desmos can be a really helpful tool in that way for these. Okay, so looking at the next problem, a word problem, make it a little smaller so everything fits. Says the dry cleaner charges $4 to clean a pair of pants and $3 to clean a shirt. You want to get at least 8 items cleaned. You have $32 to spend on dry cleaning. Then they want us to write a system to model that and then graph it. So on a problem like this, you have to kind of define both of your variables. So we have X pairs of pants and Y shirts, or you could do vice versa there. We'll just let X equal number of pants. So Y would be number of shirts. I think on my notes, I did the opposite. So this is just to kind of show you that it doesn't matter which one you choose. Based on the way I've set it up here, our inequalities would look like this. So you have one inequality that says you want to get at least 8 items clean. So that would be some number of pants plus some number of shirts. At least means greater than or equal to, so greater than or equal to 8. I'll do the other one in a different color. So now the other one would be for the money we have, right? So on this one, it's going to be $4 per pair of pants plus $3 per shirt. And if we have $32, we can spend up to, but no more than $32. So as an inequality symbol, that'd be less than or equal to 32. Okay, so now getting to the graphing part of this, I'm gonna kind of consider leaving these in standard form versus solving for Y. So remember for that, kind of graphing our purple line here, our top inequality boundary line. If we want to find like the x-intercept, then we, in our mind, just plug 0 in for y. So we kind of have x equals 8, right? So this point goes through, or this one goes through 8, 0. It's going to be right there. Okay. Same thing for the y-intercept. Plug in 0 for x, so we get y equals 8. So it goes through 0, 8 as well. And then you have your boundary line is solid because it's or equal to. And we would want to shade on this one on the high side because it's greater than or equal to. All right, and then our other one. So find my x-intercept. Plug 0 in for y, we have 4x equals 32. So that would tell me that what's 32 over 4? That's 8. So the x-intercept is on this line, also 8, 0. And then my y-intercept is going to be whatever 32 over 3 is. So that'd be like 10 2/3. It's almost 11. So that's 10, 0, so I'm going to go just above that. And also this one is solid. All right, but the less than says we want to shade on the low side of this one. So our shaded region is right in there. Now, it would have been more appropriate to probably make this a first quadrant graph, like I could keep shading this way, right? But in this case, we would never have negative shirts or negative money, which are our two quantities. So it would have been most appropriate on this one to look at just a first quadrant graph. All right, so again, could you use Desmos? You can use Desmos after you do this part. You have to be able to produce the inequalities. And then from there, if you want to kind of verify your graph, or even use it to produce your graph. See how it looks on Desmos. So, okay, so why does it look a little bit opposite? So here you can see that my kind of headlight looking thing is getting wider as I go to the left. Here, it's the opposite. So notice what I did differently on this one is it looks like I let X be the number of shirts and Y be the number of pants. So that's, neither one is wrong. It's just, you know, interpreting how I've set it up, okay? All right, so then I wanted to do one more problem, which is not on your blank notes. I somehow cut off the third page, so I'm going to rewrite one of these problems as, let me make sure I get this right. There's a couple problems at the end that may have some absolute value kind of type boundary lines on them, so I want to go ahead and look at that. All right, so we're gonna, and this is on your filled out notes, number 8. It's just not on your blank notes. All right, so we're gonna say this is number 8, which is y is strictly less than the absolute value of 2x minus 4, and x plus 5y is greater than or equal to -1. All right, so that's what we have. Now, so you look at this, and if you thought about, and I know you can already see it over there, but let's just ignore that for right now. And if we were to try to produce this graph by hand, remember, you know, this is not in vertex form, looking at the absolute value part, right? It's not in vertex form because my coefficient of x is not 1, right? So in order to kind of graph this by hand, we'd have to think about rewriting this as y is less than 2 times the quantity x minus 2. Now I can kind of look at that and tell, okay, that's 2 to the right, so my vertex would be at 2, 0, and then my slope would be 2. But, okay, if you don't want to have to go through all that, you could just type it in just like you see it. Y is less than the absolute value of 2x minus 4. By the way, the absolute value bars are located, if you can see where my cursor is here, down here where the keyboard is. So if you ever can't find anything, you want to kind of reference the keyboard on Desmos. All right, so from what I see on Desmos, I can produce that same graph. I can tell that my vertex, which is the most important point, is at 2, 0, and I can tell my slope on the right side is 2, my slope on the left side is -2. So let's go ahead and put that on our graph. Okay, it's dotted because it's strictly, meaning it's not equal to. So it is strictly less than, so that means we want to shade on the low side, below it. All right, and then our other line, x plus 5y is greater than or equal to -1. So we go to try to graph this one, and it's a little more complicated because, well, the y-intercept is, we can't really tell there, right? I think you could click and it would tell you, but you don't really want to graph a partial, like, you know, I think that's 0, -1/5. You don't want to try to really graph that. So instead, I would look at, we can tell we have a corner point there at 4, -1. So I'd graph that point. And then also, we have another corner point at -1, 0. All right, and then you can confirm that those both work because my slope between those two is -1/5. So if I go up 1 and left 5 again, I can tell that I'm on that same line. So that's going to be a lot easier to graph just by looking at Desmos on one like that. Just extend my line here real quick. All right, so due to kind of the thickness of my lines and just the air on the board, it looks like they touch, but they don't. Okay, so there's a little space here. Just noting. And then my boundary line is greater than or equal to, so we want to shade on the high side here. So overall, my double shaded region is kind of in between our two boundary lines. All right, which you can tell by looking here too. And here you can see much more accurate. You can see that spacing in between our two boundary lines there on Desmos. All right, so I encourage you guys to play around on Desmos when you're working on this. It's just another tool in your toolbox. Okay. But just remember, we got a quiz over the first half of the chapter on Wednesday this week. So I would say it'd be a great goal to be finished or at least started on your Math XL assignments for 3-1, 3-2, and 3-3. Thanks for your time, and as always, hopefully this stuff helps you to understand the lessons. Thanks, guys.